Hello, so what do you like best? Do you like stairs? Do you like escalators? Or do you like elevators? Me personally, being a very lazy individual, I like elevators. They're very efficient. You don't have to move anywhere. You don't have to step anywhere, and it gets you to the destination. Now imagine that instead of rocket ships, we could take an express elevator to orbit. Obviously, this would be much cheaper, more efficient. It has a whole range of benefits. The most would be that it'll be easy. You wouldn't have to deal with the crazy G-forces, and it gets you to the destination. Might take a little longer, but it gets you to the destination. That's what's important. In today's video, we're checking out Kurzgesagt, an amazing science-based channel. And the video topic today is 1,000 kilometer cable to the stars, the Skyhook. If you're into this type of content, this type of reactions, please make sure to like and subscribe to the video. Let's get started.
Getting to space is hard. Right now, it's like going up a mountain on a unicycle with a backpack full of explosives.
I give up after 2 rotations on a bike.
Incredibly slow, you can't transport a lot of stuff, and you might die. A rocket needs to
And you might die, yes.
reach a velocity of about 40,000 kilometers an hour to
Imagine the G-forces on that bad boy.
escape from Earth. To get to that speed, rockets are mostly containers for fuel with a tiny tip of payload.
There's the other benefit. Like, you wouldn't have to take up so much space just carrying the fuel.
This is bad if you want to go to other planets because you need a lot of heavy stuff if you want to survive and maybe even come back. So is there a way to get to space with
Hello, Mars.
less fuel and more payload?
Space elevators. Dun, 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 dun. Kurzgesagt.
A nice thing that solved most of our transport problems on Earth is what you call infrastructure. Whether it's roads for cars, ports for ships, or rails for trains, we've made it easier to get to places.
True.
We can apply the same solution to space travel. Space infrastructure will make getting into orbit and out to the moon, Mars, and beyond easier and cheaper.
Imagine you could just go on Expedia or Skyscanner or something and book your flight to the moon.
Great, but what exactly is space infrastructure? Unlike an Earth space elevator, which is currently science fiction,
Science fiction. I think the main problem is probably this material. The material science needed for something strong enough to keep all of this intact.
is a simple yet promising technology that does not require new science, magic materials, or huge investments, and that has been tested successfully in orbit already. A cable and a weight, known as a tether. The concept is so simple, it's surprising. What if we put tethers, hundreds or thousands of kilometers long, into space and had spacecraft use them as ladders to climb to higher altitudes and gain speed?
Okay, so these are already actually in orbit themselves. Okay.
This concept is known as the Skyhook. It works even better if we make it spin. A counterweight.
So this is more like a space elevator, not an elevator from Earth.
Weight holds a long cable in place while it rotates around a circle. A rotating tether slows down its tip relative to the ground at the bottom and speeds it up at the top like a catapult. This means that you can transfer energy from the tether and get a massive boost when released, more
Genius.
or less for free, equal to twice the tether's rotation velocity. Specialized fibers already exist that can survive the extraordinary stresses a Skyhook would be faced with. To protect against cuts and collisions from debris and meteorites, we can thread our tether into a web of redundant fibers. Since our Skyhook would pass over the same spot many times a day, this would allow small, reusable shuttles to catch up with it. Of course, it's not that easy. At its lowest point, the tether's tip is dashing through the atmosphere at around 12,000.
Jeez. Imagine being the pilot who has to maneuver this in space at these speeds.
Kilometers per hour. Because of Earth's atmosphere, we can't lower the Skyhook too much or it will get too hot from air friction. So it will dip to a height of 80 to 150 kilometers and no lower. To match this, we'll need specialized spacecraft that can get to the tether. While this isn't exactly easy, it's still much cheaper than getting a big tin can filled with rocket fuel.
Wow. I mean, this graph doesn't really give you, the axis is X and Y, what it means. But, in comparison, goddamn, look at the difference.
To go 40,000 kilometers an hour. Catching the tip will be a challenge too. There's only a short time window of 60 to 90 seconds to find a tiny thing in the sky moving at Mach 12. To make this easier, the tip could have a sort of fishing line, a kilometer long, with a navigation drone that helps the spacecraft connect. Another challenge is keeping our Skyhook in orbit. As more and more ships latch onto it and pull themselves up, they use up the momentum that keeps it in place.
True.
If we
it would be falling, the orbit should decay into the Earth.
Don't do anything, it will slow down and crash into the atmosphere. And here, we can cheat the universe a bit. The Skyhook is a battery of orbital energy. It's possible to balance the payloads coming in and being sent off. Arriving ships bringing humans and materials home to Earth add energy to the tether, which it can give to us.
Imagine you combine this with if you haven't checked out my last video about space mining, check it out. Imagine you combining with those concepts together with these.
The ships departing into space. This way, the tether doesn't lose any energy. The more we use it, the cheaper it gets. If we're still losing energy with each boost, we can recover it with small electric or chemical engines that regularly correct the tether's position. A set of tethers, one around Earth and one around Mars, could make trips between the planets fast, straightforward, and low cost compared.
Imagine that. You're getting slingshot from Earth to Mars.
To rockets. The Earth tether would sit in low Earth.
And you wouldn't have to kill a whole bunch of fuel to just slow down to, oh my God.
Orbit to grab people.
It solves so many things.
And payloads and fling them off to Mars. The Mars tether catches them and slows them down for a landing on the surface. In the opposite direction, the tether could pick up a vehicle traveling through Mars's thin atmosphere at only about 1,000 kilometers an hour, not much faster than our airliners on Earth, and fling it back to Earth to be caught and lowered down.
So it's much easier on Mars, smaller planet, and no atmosphere, I guess.
The tethers could shorten trips between both planets from 9 months down to 5 or even 3, and reduce the scale of the rockets required by between 84 and 96%.
Yo, this is insane leap. Like, why isn't anybody working on this? This is major.
Even better, people may be able to travel in relative luxury, as we could afford to invest in passenger comfort. Tether travel would be first-class seats to Mars. Together, tethers around
Where's my ticket?
Earth and Mars could provide the rapid and cost-efficient transportation backbone that would make space travel affordable. But let's go further. Starting from low Mars orbit, a tether could boost ships to the asteroid belt. The first craft sent to a new asteroid would need rockets to slow down at its destination. Subsequent arrivals might find a tether waiting to catch them and send them back for free.
Imagine now putting these things around every place we want to go visit. Wow.
Getting to asteroids cheaply is a major factor in opening up the resources of the solar system. Precious metals and valuable minerals could be delivered to Mars just weeks after they were cut out of their asteroid. They would
Weeks? What?
Be the perfect building blocks for our interplanetary civilization. But why stop here? Mars
Oh my God, okay. Even more potential.
Moons are very convenient. No other moons in the solar system orbit that close to their planet. Phobos is so heavy that we don't need to worry about slowing it down, making it the perfect attachment point for super tethers just under 6,000 kilometers long.
What? Oh my God, using a literal moon of a planet for the tethering.
The lower tip would fly just over the surface of Mars.
This is getting ambitious, very ambitious.
And be very easy to catch. The upper tip can fling ships all the way to Jupiter and Saturn. The same super tether can also bring the inner solar system closer. Venus and Mercury are a single swing away. Unlike Mars, they're bursting with solar energy and are rich in minerals. In the long term, nothing is stopping humanity from constructing a zero-propellant transport network for the terrestrial planets centered on the Martian moons.
Wow.
Tethers are
Imagine, no fuel needed, just kinetic energy with these tethers to get around the solar system. A whole network, like a highway of of tethers. Wow.
Comparably cheap and sustainable solution to making space travel affordable and the rest of the solar system accessible.
And imagine you just chain these together where, like, you know, you tether from Earth to Mars, then you take another tether from one of Jupiter's moons, you know.
For exploitation and exploration. Considering that we have the technology to build them today, there's really no good excuse to wait any longer. Parts of the solar system are far away, but they could be very close. Speaking of stuff that's hard to reach, but doesn't have to be, knowledge.
So that's the end of the video. What do you guys think? Is this more science fiction? Do you think this is very efficient? I like the concept. It solves a whole handful of problems. The biggest being fuel consumption, and also the mass of the ship being consumed mainly by storing energy, fuel, to get back and forth. So this cuts all of that out and opens up so many new opportunities to travel all around the solar system. And apparently it's even much faster too. I don't know. Kurzgesagt sold me on the concept. Is there something I'm missing here? Is there something that makes this unrealistic? They say there's the materials already to create the tethers that would survive long term. So, I mean, why freaking not? Why hasn't this been started yet? Do you know? If you do, leave a comment below. Also, if you enjoyed this video, make sure you hit the like button, subscribe, and let me know if you have another video idea that I should go check out. See you in the next one. Thanks for watching.